So today I am presenting the Gauss-Seidel method using C++ programming. But first, let's have a quick discussion about Gauss-Seidel method. So Gauss-Seidel method introduces a newly computed variable to the next computed variable rather than the next iteration in order to forcefully accelerate convergence, thereby improving set of computed variables for the next iteration. This will be the graphical substitution process for Gauss-Seidel. So we have three steps when solving Gauss-Seidel using manual if we are solving manually. So step 1, we rearrange the order of equation in a manner that the dominant coefficient for each unknown variable lies in the main diagonal of the system of linear equations. Step 2, obtain the iterative formula for each variable by transposing the dominant variable and dividing the equation by the dominant coefficient. So step 3 is begin the iteration by substituting the initial values by 0 to evaluate the first variable. Then it is substituted onto the next iterative variable to obtain their new values. So the process is repeated by substituting the variables on the next iteration until the terminating condition is satisfied. So this is the algorithm for Gauss-Seidel using the program C++. And here, this will be the equation we will be using in the program. So we have 3x plus 20y minus z equals negative 18. 2x minus 3y plus 20z equals 25, 20x plus y minus 2z equals 17. So before we begin in the C++, let's rearrange first the order of the equation in the manner that the dominant coefficient for each unknown variable lies in the main diagonal system of the linear equation. So here it is, the main diagonal of the system of linear equation. Here. And then next, we will put the coefficient in augmented matrix way. Okay, now let's start the simulation. So this will be the code we will be using in the program. So I will be using the online compiler. You can you can search it on Google. Just type online compiler. Okay, so here it is. And now we will be putting the code. So in this code, we will be asked to enter the amount of, rather enter the number of equations. Next, also we will be asked to enter the element of augmented matrix row wise. Next is the enter the initial values of the variables and then enter the accuracy up to which you want the solution. And so on. And then now run the program. Okay, let's click the run. Okay, here we are asked to enter the number of equations. So from the equation I've shown you earlier, we have three equations. So we will put 3, enter, and then again we are asked to enter the elements of augmented matrix row wise. So from this equation, okay, we will put 7, 2, negative 3, and 22. Next is 2, 5, negative 3, and 15. Next is 1, 1, 6, and 21. Okay. Next, we are asked to enter the initial values of the variable. So we will put 0. Next, enter the accuracy up to which you want the solution. So we will put 0 0.001. Enter. So here, this is the terminating condition, and after entering the condition was satisfied and on 8 iteration with the root of x0 equals 3.2857, x1 equals 3.1429, x2 equals 2.4286. So that's all for Gauss-Seidel method.